have a couple of highlighters for this part. Okay. In grade 11, I called them the story type. Okay. So this is what we're going to go with here. The fact that you are usually provided with 2 points, but you need to find the third point using the symmetry of the curve. Okay? And the main idea is to remember that the third point is across from the starting point. That is huge right there. I'm going to give that another underline here. Can't miss that. So regardless of where you're at, okay, you could be starting on the ground. So then this point right here is 0, 0. And imagine that the ball is kicked from the ground and you reach a maximum height of 17 feet after 1.25 seconds. Right? So then this point here, they're basically talking about the vertex. How do you know it's the vertex? It's the maximum height, right? Okay, so now, how do you come up with a third point? Because you need 3 points. Always, guys, I'm going to use a color here. Oh, where do you start? You start at 0, 0. Keep going until you hit the curve again. Okay? So you can find the third point, which is located right here. And how are you going to find that? What's the height at this point? The same as what you started, right? Our height here is 0. How long will it have taken us to get there? Twice as long. If it took us 1.25 seconds to get to the middle, okay, 1.25, it's going to take us another 1.25 to get back to where we started, same height. So essentially, we take this one and multiply it by 2 and get 2.5. Okay. And now you have everything you need to come up with your equation. X, Y. You just put the points in. 0, 0, 1.25, 17, and then 2.5, 0. Okay. This would go into L1. This would go into L2. You're in business. Another one here. We're starting off the ground, okay? Off the ground. So let's read this real quick. An object is thrown from a height of 8 meters. So that means that what? This is what? 0, 8. And then we reach a maximum height, that's the vertex again, right, of 13 meters at a distance of 3.5 meters. And you just have to make sure you don't mix that up. Distance comes first, then the height, like that. And guess what? This is where my color comes in. You started here, correct? Travel across until you get back to the same height where you started. So you're off the ground here. What's my Y value at this point? 8, right? Yep. What's my X value? You take whatever it took to get to the halfway point and you just multiply that by 2. So this would be 7, 8. So it takes you 7 seconds to get back to the same height, right, from the starting point. Please don't say that this down here is 7. Some students put 7, 0 down here. That's not correct. So always go across and look across the curve. So here you have X and Y, 0, 8, 3.5, 13, 7, 8. Okay, so it goes into L1, L2, boom, you got your quadratic right there. Okay, let's keep going. Just one more example here. I think I'm going to talk about an object is thrown upwards, reaches a maximum height of 40, then lands and remains airborne for 8 seconds. This right here, we know this is 0, 0 because we're throwing it upwards. Doesn't tell us we're off the ground. It takes us 8 seconds to land again. So in this case, I give you the end point and the starting point. But you want to get to the vertex. You want to get one more point. And with symmetry, vertex is where it's at. Okay? So we know that the maximum height is 40. What will the x value be in this case? Half of it, right? Half of 8. So you just divide it by 2 to get 440. And now you're in business. You got your 3 points again. Okay? So this would be xy, 0, 0, 4, 40, and then 8, 0, like that. I think I'm going to stop there. I think you get the picture, hopefully. Let's do an example right away so you know how to work this. So read that for 1 second there. I'm just gonna see where I want to end up today. Yeah. Okay. So I just want to say this. The only challenge here is, the only extra challenge is you need to come up with the points yourselves, and then with an equation, and then it's back to word problems with an equation, right? Like it's basically the same thing. So I'm just going to focus on finding the equation with you. Roger would like to recycle his beverage container, throws his container up from a height of 1.75 meters, and estimates that it reaches a maximum height of 2.8 after 0.75 seconds. This right here is the vertex, if you haven't noticed. A maximum height, right? The container lands on the rim of the recycling bin, and the bin is 0.65 meters tall. Determine the quadratic equation that models the path of the container. Okay, let's make that little sketch here. This is time. This is height. Where does the action start? On the ground? On the ground or off the ground? Off the ground, right? At 1.75, so it's somewhere here. Then it gets thrown up. We know that it reaches 2.8, and then it lands on the rim of the recycling bin, right? Is the recycling bin shorter than the initial? Is it lower? Yes, right? Right here. It hits the rim somewhere here. And I'm trying to trick you here. Let's see if you fall. I'll give you treats if you get this right. Bribe you a little bit. This is 2.8. No, I got that wrong. Time first, height second. 0.75. 2.8. Now, this one right here, I don't know how long it will take to reach a height of 0.65, correct? Don't fall for that one. You have these 2 points, correct? We use symmetry. We're going to start here and travel across until we reach this point right here. What's the height there? 1.75, correct? And what is the x value at this point? 1.5, correct. I'm going to go times 2, so this is 1.5. So what about this one? It may come back later. Okay, but right now we cannot figure out what this is. It's not directly across where we started. So these are our 3 points. So all you do is X and Y. Write them out nice and clearly. Okay, 0.75. A lot of 75s here, I know. And then you go 1.5, 1.75. You let this, right, you enter that into L1, this into L2, stat, calc, quadratic regression. Okay? And what are we going to get? You should try it. We can do a zoom 9, and it has, because you only have 3 points, right? These are the 3. Please make sure you adjust your window though later when you do the actual calculation. I'm going to go stat, calc, quadratic regression, 1, 2, alpha trace. You get negative 1.87 x squared plus 2.8 x plus 1.75. No surprises that it's 1.75 at the end, I hope. Because that is our initial height. That is the quadratic equation. Hit graph. Perfect. Except for the window. So my x min is pretty good, but I'm going to go negative 1 there at least. And my y min, I'm going to also change that to negative 1. Right? That way you see the quadrants around it. You want to increase your x max a little bit. Okay, we're going to go 2.5 or something like that. There you go. That is a pretty good graph. And now you can just use that to answer anything the question throws at you. How long, for example, does it take for the beverage container to reach the rim of the recycling bin? We know that that is at a height of 0.65, correct? So now I'm going to answer that question. I'm going to answer this question right here. I'm going to let y2 equal 0.65. And then second trace, intersect. Okay. Let's do that. 0.65. There it is. It only hits it right there. If it hits this on the way up, you would ignore that one. You would only want to consider when it's on its way down. Enter, enter, enter. And there you have it. X is equal to 1.82 at that point. Okay? So if you just say 1.82 seconds, you are correct. How long does a container remain below 2.5 meters? Sorry, I'm a little off there. How long does it stay below 2.5? I would hope that you at least know. Let's enter that into y2. And we'll go 2.5 there. Second trace, intersect. Let's go ahead and do that. 2.5. How would you do this? If we find these two intersections and we subtract the times, we're going to find the time above, correct? So we're partially there. We want to know the time below, like this stretch right here and this stretch until it hits the rim. That's what we want to know. So I'm going to use indirect reasoning here. So watch what I will do here. I will go time above is going to be, let's find those two times. Second trace 5. I'll find this one first. That's 1.1509 minus second trace 5. That is 0.3491. When I subtract that, you get this, 0.8018 seconds. That's the time above. It wants below, correct? What's the total flying time? Exactly. It hits the rim here. It stops flying. So from start to finish, it's 1.82. We're going to take it away. We're going to subtract these two for time below. So time below, it's going to be total minus time above. So it's 1.82 minus 0.8018. And that is 1.02 seconds if you round it. And I will just always encourage you to read very carefully when you do these ones. Okay? Is it in the... Yeah? Okay. We're going to go domain and range. Or should we graph it first? Oh, graph it first. Time, and this is, we are in seconds. And this is height in meters. I need to make sure I have enough space for everything. The highest is 2.8. So 1, 2, 3. That'll work. And for time, if I'll make this 0.5, I'll make this 1, 1.5, and 2. 2.5 like that. That should be enough. 175 is right there, 0.175. 0.75, 2.8 is right about there. And 1.82, this is 7582 somewhere here. 0.65 is right there. Okay, so in this case, it just does that. It flies to the highest point and lands on top of the recycling bin. Domain 0 to 1.82, because we're talking time. For the range, it's going to be, what's the lowest point we ever get to? The rim of the bin, right? 0.65. And the highest we ever get to is 2.8. There you go. It was a long one today, I know. I'm very aware of that. I apologize for that. 59 to 60. Try them, okay? Make sure. I will also, because we need to be pretty good at regressions. I'll give you one AC to take home and complete by tomorrow. But please don't let this one go to the wayside, right? You want to make sure you try that as well.